Hello everybody, Adam Lusek here, and if you've been keeping up with the releases of major language models and open source language models, you have sure to have seen that about a week ago, Gemma 2 was released from Google. And they released this with two weight options. They have the 9 billion parameter and 27 billion parameter options, and according to what's looking like the initial benchmarks, these are pretty competitive to a lot of the mainstream open source models like Llama 3 8B, Llama 3 70B, and Grok 1, which is coming in at 314 billion parameters. The Gemma 2 models at 9 billion and 27 billion are relatively comparable, if not outperforming a lot of these models. And so seeing Gemma 2 9B's comparison to Llama 3 8B and seeing how it was outperforming, if not equal, I knew that I had to put that to the test. As Llama 3, the 8 billion parameter model, has been my go-to local model for running locally on my laptop and putting together fun stuff like this local web search research agent that I have a video on here. So seeing that this was competitive and also available to be ran locally, I knew I had to put it to the test and try some stuff out. So to do that, I came up with the idea of plugging Gemma 2, the 9 billion parameter model, into a bit of a YouTube assistant to, maybe see if it was decent at helping me out with stuff like this, and then also applying some different techniques like reflection to see if it can do multiple things. Stuff like generate novel ideas, analyze different content, and then also how well it is at regulating itself with reflection-based steps in more of this overarching agentic style. And so that's what we'll be going over today, how I set up this local reflection agent using Gemma 2 9B, and then seeing how well it performs and is able to do all of those tasks. So to give a broad overview of sort of what we're going to be putting together and how this works, we're going to be using the YouTube Data API to pull all of the information about some sort of large account. Think something like, Mr. Beast or Mark S. Brownlee, and pull all of the data from that channel and then also the YouTube videos. We're going to pass that through to a first step that'll have Gemma 2 actually take all of that information and create a report about the channel, and then more specifically about the different techniques and styles used for writing the titles. We're then going to run it through a reflection and validation step where it'll look at that and validate that the report was done well, and then if there's anything else that needs to be done, it might kick it back with further instructions. If not, it'll pass it off to a second step, the generation step, where it'll attempt to apply those ideas that it researched to generate new titles based on some sort of new topic that we give it. Also, similar to the report step, it's going to be then kicked back to a reflection and validation step where it'll look at that and see whether or not the titles are adequate or follow sort of the report that it's given. If it is, it'll pass through and then submit the final report. If not, it will generate until it's happy with its results and then finally pass it all off to us. So in short, it's going to take all of the data that we grab from YouTube's API, generate a report, generate titles, and then at each step along the way, going to be running through some basic reflection. And so I have another video that goes over all of the different types of sort of agentic architectures that are out there from basic to advanced. This one being just a 9 billion model is one of the more basic ones, but you can check out this video that's popping up right now to see more of those overarching architectures that you might be able to apply to different projects like this. So with that introduction out of the way, let's actually go into how this is set up and how you can set up something similarly yourself. The first thing, of course, is that we're going to be using Ollama and Ollama's integration with Gemma 2 to actually be running and using this model locally. And so, of course, make sure that you've got that downloaded and then run some of the necessary steps to actually download the model onto your local machine as well. That, of course, once you have it downloaded, is just Ollama pull Gemma 2. Once you've got that all set up, of course, the first step is then going to be running through the YouTube Data API. I have a couple links here that you can check out if you want to learn more about the YouTube Data API. The first one gives you sort of their homepage that has a good overview, and then the second one will actually show you how to set up your account and get the API key. This is, of course, completely free. There's a daily quota of about 10,000 calls, and every time we actually run this full program, it's only going to use 3 of those calls. So you shouldn't run into any of those issues, and it should maintain its completely free claim all well. But once you have that set up, I have this nice long function here that will get all of the channel information for you and also start the YouTube client with your API key. It starts this object here by using the build function with YouTube, the version of the API, which is version 3, and then passing in your API key, which I have set already, but you can just uncomment out this and put that in here, and that should work well. But then what our main function here does is it takes in a channel ID. And the channel ID can be found on pretty much any YouTube channel by just clicking on this more and then going to share channel and then you can see copy channel ID. So that's how you find the ID there. I've got a list of them at the bottom of this as well that you can use for reference, but that's what we're talking about when we're talking about the YouTube channel ID. But essentially, this function will make a first call doing a list of the channels with the ID that'll grab the statistics, different snippet, topic details, branding settings, and content details. This is all outlined in their overview and documentation, but essentially it's going to allow us to grab the channel name, different statistics about it, and then within the snippet is also other parts of the thing like the channel description, and then we can get topic details, which are also listed in the back end, different branding settings, which have some other keywords in there, and then also the uploads playlist ID. And the uploads playlist ID is really important because what YouTube does in the back end is it actually looks at all of your uploads as a playlist. So what we can do is we can use that upload playlist ID to then list out all of the videos that you've made. And so grabbing all of that, we put it into a quick dictionary here and then leave a space open for recent videos so that we can do that in the next step. To handle populating the videos, we use this get recent videos function, which is down here, which will make another call using the playlist items where we can pass in the uploads playlist ID that we grabbed. And then from that, we can grab the video IDs and then do one more call that will list out all of the videos, grab things like their content details, another snippet part, different statistics, and different topic details, map them to their video ideas. And then back here in the original function, we're able to grab stuff like the title, different URLs of the video, the view count, the like count, the comments, and then the different tags that people have put. We then shove that all into the main channel info dictionary that we've got here in the recent videos part, and then return that. So let's test this out and just see what's happening there. So if I go to a channel that I enjoy watching, like Ludwig here, what we can do is grab the channel ID, go back here, pop that into our get channel info function, and then that'll go through, and here we go. We get the channel title, the description, current subscribers, views, different channel topics, the keywords, and then all of the videos are listed out here with the title, likes, and comments. So that looks great. So now that we have all of that information, we want to pass it off to then the language model. And so for that, we're going to need to set up the different prompts, one for generating the report, one for generating the title, and then one that is able to do the validation at each step along the way. One super crucial thing to note about local models like Llama 3 or Gemma 2 here is that we need to use sort of different special tokens when we're setting up our prompts so that the models themselves can actually process the information and generate correctly. If you don't use these things, sometimes it can go way off the deep end and just keep generating forever and ever until it eventually times out. So I've grabbed this snippet from the technical report that I have linked at the top of the page that shows all of the different relevant tokens that you need to be careful to use when you're setting up the prompts to make sure that generation is done successfully. This is essentially just going to be able to delineate where exactly we're putting in the user messages, where we're putting in the assistant messages, and how to actually insert things like a system message that stuff like OpenAI, Llama 3, that all of these models expect to see before they actually start their generation. So you can see that there's about 6 here. You can have a user, model, start of turn, end of turn, beginning of sequence, and end of sequence token. And setting them up actually in a conversational style generally follows this flow where you have to do start of turn and then either the user or the model to delineate between a user response or an assistant response. And then at the end of that, you need the special end of turn token. And then all the way at the end, you have to have an end of turn, end of sequence to delineate that it's the final sort of step. It's a lot easier to actually understand this when we're looking at some real prompts and seeing them in action. So let's actually just get to that too. And so what we're going to be using is LangChain's integration with Ollama, Chat Ollama, and all of these functions that are outlined here that I have linked to be able to set this up. And so to do this, what I do is I first define the local LLM as Gemma 2. This is what Ollama understands as Gemma 2, the 9 billion model that will be expecting all of these special tokens. And then I pass that through the Chat Ollama function to set up the different language model objects. And so I have 2 here. I'm going to set up a regular object with Chat Ollama, pathing over to Gemma 2, and then having the temperature as 0.07 or 0.7, and then also a JSON mode one that follows the same thing, Chat Ollama with the model, with the format equal to JSON, and then the temperature as 0.7. And we'll see where the JSON actually comes into play a little bit later. And so then, of course, the first prompt that we need is the generate report prompt that will be able to take in the YouTube data and generate our comprehensive report. So scrolling back down to here, you can see now how the special tokens come into play and the prompt that I wrote. So we have a beginning of sequence token to delineate that this is the full beginning. It's not some partial generation of this entire sequence. We have a start of turn user, and then this is where I'm putting in most of my prompt here. So I have, you are an AI assistant for YouTube analysis tasks that reports the main findings of a YouTube data poll. Your main goal is to analyze how the account formats and creates their YouTube titles. Carefully analyze the YouTube titles and any other useful information and create a short report that covers everything one may want to know to imitate their success. Be as specific as possible with your analysis. And then I set in some placeholders to dynamically insert the information at different steps. So I have one for the reflection step that has additional instructions, if any, where we'll be able to dynamically insert the different instructions that we get at the reflection step, which we'll get to in a little bit. And then of course we have a regular set for the polled YouTube data where we're going to put in data. And then I have begin your response and then end of turn. So this end of turn is ending the user turn. And then to kick off the model generation, we started out with just a start of turn model. And so when the model Gemma 2 actually sees this, it'll process all of this and then see that it's the start of turn model and note that now it's time for it to actually generate the model's turn. And so using all of these different tokens and setting it up in this way will allow us to effectively prompt Gemma 2 and have it know exactly when and what to generate where. To put this prompt into action, we're going to be using LangChain's package with prompt template and then have the template as all of the text. Specify that the input variables that can go in are data and reflection, which are right here and right here. And then we're going to put it together into a LangChain chain. So we pass the prompt to the model object, which we defined up here. And then I have a string output parser, which will take the response from the language model and then return it just as a regular string and cut out all of the extra information that might be there if you don't actually put this here. This is just to make it super easy to process and pass along down the line when we're doing it. So let's actually test this out. So we have channel info, which is what we got up here and saved here. So let's run this through our prompt and see what it is able to generate. Sweet, so after a little bit of time, this is everything that it put out, and it likes to do its generation in Markdown style, so I'm just using the IPython package to display this all in Markdown so that we can load that and have it look all nice. So it's given us an overview that this is Ludwig's YouTube channel, features, etc., etc. And then the key findings are the hook-driven titles, different things of personalization, frequently uses I in his titles, creating a personal sense of personal connection with the viewers. And then different challenge and competitions, often sets up challenges for himself, things about emojis and punctuations, different keywords, and then putting this all into recommendations. Craft hook-driven titles, personalize your content, set up challenges, utilize emojis and punctuations, incorporate relevant keywords, and then a little conclusion about Ludwig here. So this looks phenomenal and this looks like a really good report. So let's see how it's able to ingest that and then actually do the title generation. Which brings us down here to our second prompt here, the title generation prompt. So similarly to the last, I have the special tokens, begin of sequence, start of turn user, and then my main prompt is here. It says you are an AI assistant for applying YouTube analysis reports to create new YouTube titles. Your coworker has created a report that analyzes and creates suggestions for creating new YouTube titles. Your goal now is to apply these learnings to craft potential YouTube titles about a new topic. Carefully analyze the report and apply the learned techniques to generate 5 new titles on the new topic. Ensure that you are directly applying the techniques outlined in the data report to your generation. Add a short explanation as to how each generated title follows the report findings. List in Markdown format. And then, of course, I have the different places to dynamically insert what we need. We have the reflection, if any, the YouTube data report, which is what we generated right here, and then the new topic, which we'll pass in. And then I have, if additional instructions are present, then this is a revision step. You are to follow the instructions to improve upon your prior generation. That will be listed with the additional instructions. And so that is just delineating what to do if we get any different reflection instructions here from the reflection step that we'll go over shortly. And so, of course, we package this all up into a chain that goes through the prompt to Gemma 2, and then just a simple string output parser. So let's test this out. So this topic I have is, of course, building a YouTube title generator AI agent with reflection using the new language model from Google, Gemma 2 9B. And so we'll input the report, which we have up here. the new topic, which is this topic, and then I'll just leave the reflection blank for now and see what it's able to come up with here. So here we have 5 different examples, and it looks like it has sort of applied the different report findings to try and make some different YouTube titles. So it's got stuff like, I built a YouTube title generator with Gemma 2. It's insane. Trying to use emojis for emphasis following Ludwig's style. For the challenge-driven approach, it's got, can Gemma 2 9b write better YouTube titles than me? And then it's got things like drawing attention and incorporating keywords. My AI YouTube title generator learns from its mistakes. Gemma 2 reflection. So yeah, I mean, I would say that if it was applying the different report findings, this might be decent. But let's see what Gemma 2 itself thinks, if these are decent or not, based on this plus the report context. Bringing us then to our final step that we need, the reflection step for both the report generation and also the title generation. And so the reflection prompt is a little bit looser because this is going to be called twice. I need it to be called first for the actual report generation and then second for the title generation. So this is how it sort of follows. We have, you are an AI assistant verifying and validating the current analysis workflow to ensure that ideas are applied and unique. The current project is to analyze a YouTube channel, create a report about the video titles, and apply the learnings to create titles for a new topic. Your task is to verify that these steps have been completed and are of high quality. Observe what's been written and either approve or deny. Provide any additional instructions for what may be necessary to fix if denied. And then we have a few things here. We have work to analyze from the, and then I can dynamically insert with sort of the input variables what task the step is. And then I have the candidate here, which is where we can put in the part to actually either the report or the titles generated to either approve or deny, and then the context, if any, for what the generation is based on. And then the context is going to be, if it's the report, the data that was pulled, or if it's the titles, the report that it was generated with. And then this is where our actual JSON format comes into play. We have return your answer in JSON format with no preamble or explanation, as such, with verdict, approve, deny, and then instructions, further instructions, begin your response. And so this is where we're actually going to be using the JSON mode of Chat Ollama. And what we're going to be able to do with that is that this step, the reflection step, will give us a verdict, approve or deny, and then instructions if necessary. And then we can parse that with the JSON output parser when we put it into a final reflection chain that will have the prompt, pass it to the JSON mode of this model, and then parse it with JSON, where then we can grab both the verdict and the instructions at once when this is output, and then it's all in a nice parsable format instead of just plain text where we'd have to do other steps to actually parse it out. So let's test this out and see if it likes its actual title generation that it did in the prior step. So we're going to pass the task as title generation. We're going to pass the recommendation, which is what we saved all of these titles as, and then the context is the report, which is the report up here. So that will go through and then say either approve or deny, and then give any further instructions. So it approves it, and then there are no further instructions. So this would be a great success. So now that we have all of these steps and that they all work, and we validated that all of the prompts are working great, what we want to do is now set up this full flow and have it be fully automated and do all of these steps, like kicking it back to the different generation steps if it's invalidated by its reflection step, and then also passing it off to the reflection, and then also finally passing everything off to the user, all in one sort of nice agentic system. And so that's where we're actually going to use all the way down here. Oops. Went a little too far. LangGraph. LangGraph is another one of LangChain's offerings that makes it really easy to sort of package up different information and create these more complex agentic LLM-based systems in sort of a nice, fully contained environment. From their website, they claim that it's a library for building stateful multi-actor applications with LLMs used to create agent and multi-agent workflows. Compared to other LLM frameworks, it offers these core benefits: cycles, controllability, and persistence. LangGraphs allows you to define flows that involve different cycles, essential for most agentic architectures, differentiating it from other DAG-based solutions. And so in simpler terms, if you've never sort of approached a LangGraph setup before, LangGraph lets us pass all of our data along on sort of a different set graph. So we're literally going to be building all of the connections here. And at each point here, there's going to be some sort of processing step where we're able to grab what information we have, do some processing, and then pass it back to a state. which the state is going to maintain all of our information and pass it along to these individual nodes that do some sort of different processing at each step before it's finally all output to the user. If you've never worked with sort of state-based or graph-based architectures like this can be a little difficult to wrap your head around. So let's actually look at how I've set this up and the different explanations of what's going on at each step are so that you can hopefully better understand it. The best way, of course, to understand these things is to put them into practice and try to make your own. So hopefully this gives you a good starting point to look at, and then you can see how I set mine up. The first thing, of course, is creating the state that will be passed along on the whole pathway and agentic journey. And for my state, I have 6 different values that are going to be held here. I've got the task, which will track the current task that's happening. I have the new topic, which will hold what our new topic for generating titles will be. I have the YouTube data, which will hold all of the information that we pulled from the YouTube data API. I have the generated report field that holds the generated report from Gemma after it is generated. Generated titles, which will hold the generated titles from Gemma after they are generated, and then reflection, which will hold the dictionary and the JSON output from the reflection step that contains the verdict and additional instructions. And so all of these are going to be kept in the state and passed along, and this data can then be either pulled from or put back and updated dynamically at each step along the way. And each one of these steps is referred to as a node. And so that is, as I keep going up here, exactly what we're going to be building here. We're going to have 1, 2, 3, 4 nodes. One for the YouTube channel ID, one for generating the report, one for generating the titles, and then one for actually doing the reflection and validation. And all of these nodes are set up as functions that will take in the state. And so this first one is going to be, of course, getting the YouTube channel ideas. And so what this will do is actually just use 2 simple input functions here that will ask what the channel ID is and what is the topic that we're applying this analysis to. We save these as channel ID and new topic, and then we also run through and get the channel info from the channel ID. And so what then we can do is pass back this dictionary string, and this is how we're actually updating the state itself. And so into the YouTube data field, which we have here as a string, we're going to put in the channel info that we get from the get channel info function. And then also as sort of a starting point, what we're going to do is just pass in a blank reflection step, which will handle sort of where the initial generation is sort of expecting some input. It'll just put in blank values there that we can then later populate if necessary from the actual reflection node. And then, of course, we have the new topic, which is going to be from this input function here that's going to update in our state the new topic field here. And then we're just going to pass in initiate as the current task to keep track of that. So all it'll do is take these 2 inputs, calls the channel info function, returns the data back to the state, updating the YouTube data and the new topic fields. We also manually update the current task field to initiate and input a blank placeholder into the reflection field so that before we do any reflection, our initial steps will not throw any errors due to missing values. So all of this encompasses all the handling that we'll do for actually grabbing the YouTube data and then updating our state that's going to then get passed on to the generate report node with all of the necessary information that we can then grab from it. And so then the second node is, of course, doing that report generation. And what it's going to do is it's going to take in the YouTube data from the state, which is kept in the YouTube data field, which we just updated here with our channel info, which is being stored as a string right here. And so we're pulling that in, and then also any reflection instructions, which might be happening from a later step if we get kicked back with reflection. And then we're formatting our inputs so that we can invoke our analysis chain and our analysis prompt that we actually put all the way up at the beginning in the prompt section of this. We have data and reflection, so we pass in the YouTube data and the reflection instructions, which if we go all the way back to the prompt, it's expecting the data here and the reflection, so that's why we're putting those in the inputs. And then we're invoking this chain here. So going all the way back to node 2 here, we are invoking the chain, and then that's how we're going to generate our report. And then what we're going to do is update the field from our generated report part right here in the state, and then also update the task. To follow this in order, we're actually going to skip node 3 real quick to talk about reflection. And so reflection, this is where it's going to take in all of the context, do its little bit of reflection, either approve or deny the quality, and then pass through any additional instructions back to the node and back to the step if it needs to do that regeneration. And so right here, we're going to take in the state, and then this is where we're now going to take in the task, and then also take in the new topic. And so why we're updating the task is that so we can see whether it's generating the report or generating the titles. If it's generating the report, it'll take in the generated report, pass in a task as YouTube report generation, and then pass in the candidate for reflection as the generated report. And then also right here, I actually have the context as none, and I'll get to that in a bit. But if we pop back to the reflection prompt, we can see that this is where the task is going to be updated. So it's going to say YouTube report generation. And then this is going to be where the report is put. And then here in the context, for at least the report, we're going to put none right there. We pass those inputs then into the chain to get the reflection, and then we can pass the reflection back to the state here with just this dictionary and reflection, which will then hold that output, which in the state is being kept as a dictionary, because if you remember, it'll have the approval and then also the further instructions part that we pass in as a JSON dictionary right here. So that will go right there, and then it will do some logic then based on whether it's approved or denied. A little bit differently, if the task is generating titles, which we'll get to here in a second, what we're going to do is grab the titles, and then we're also going to grab context, which is going to be the generated report, and then we're going to pass our inputs in as applying YouTube report findings to title generations about this new topic, which we pulled here from the state here, and then we're going to pass in the titles, and then the context, which is our generated report, invoke the reflection, and then pass it back with either the verdict of approve or deny, and then also any additional instructions as a dictionary back into our state to hold it there. And so one of the reasons that I actually pass no context in with the generated report is that this is the first downfall that I actually saw with Gemma 2, is that passing in a lot of JSON formatted or dictionary formatted data actually confused it a lot when I was passing it in as this context, and it wasn't able to sort of maintain its prompt accuracy with returning just approve or deny. When I passed in all of this JSON data, along with sort of other further instructions, it always seemed to confuse it, and it would just return back a generated JSON that completely wasn't the approve or deny. It actually followed the different dictionary parts of the report that was pulled, things like this. So that is sort of the first downfall that I saw, which is why I'm not actually passing all of this in and just doing a basic reflection with no additional context as to whether the report seems good or not. However, to round things out, we also need to define our node for generating titles with the report, which is going to be this gen titles that takes in the state. We're going to grab the report from the state now, which is held in the generated report part, which is just this string here that we updated all the way back here with the report passing into the field of generated report. So that grabs that. And then this is a little bit of handling to see if there are already titles and if they need to be passed along through the reflection. Because during the reflection step, what we want to do is also have it get the prior instructions if need be, plus also know what it generated previously so that it doesn't just keep generating the same thing over and over. So we check to see if it's not none, which means there are titles in there. And if there are, what we do is we grab the reflection plus the instructions and then append the different generated titles with prior generated titles and pass that through as our reflection instructions. If not, we just grab the regular reflection instructions to pass through, which, if it's approved, is generally nothing. And so then we grab the different new topics, and then our inputs to the title generation prompt are as such. We pass in the report, we pass in the new topic, and then we pass in the reflection. And if we go back up to the prompt here, for generating the titles, we can see that the additional instructions are passed in here with reflection, the YouTube data report is passed in here with report, and then the new topic is passed in here with here. So that's why we're formatting those inputs like that. And then we pass that all to the chain that we defined earlier to get the generated titles, and then pass those back up to the state here, updating the task as generating titles, and then updating the field here as generated titles. So now that we have all four nodes clearly defined, what we need to do is put together the graph and then also put together the different connections between them to show how they're able to talk to each other and how they're able to actually pass the state along based on different logic. So this involves adding the nodes to a workflow, defining the entry point where we actually start, connecting the nodes to each other either through direct connections, which are called edges, or through different conditional edges, which support different custom logic that we have, which we're going to need to use and go into detail with our actually reflection part, and then compiling it into our final agent. So just to reiterate our flow real quick, what we want to do is grab the YouTube details, generate a report, reflect on the report. If it's denied, go back to the generation step. If it's approved, go on and generate titles with the report, reflect on the generated titles. If that's denied, go back to generating titles. But if it's approved, end and display all of that information to the user. Doing that with the LangGraph package looks a little bit like this. We're first going to create a helper object using the stateGraph function and pass in our class, the graph state, which is our defined graph state up here. And that is going to be where we're then going to be able to use a lot of the different methods to actually add in the nodes and add in the connections. So adding in all the nodes is pretty easy. We just do the method add node, and then we put in a name for them, which all that I'm doing is using the same name as the function, because then what you need to do is alongside the name, also have the function that's defined up here of what those nodes are. So we pass in the get YouTube details, generate report, generate retitles, and the reflection steps, and then also their different functions that we defined earlier. We then need to define a starting point, and of course that's going to start with getting the YouTube details. So we put in that node's name here with the get underscore YT underscore details. And then what we need to do is define exactly how the different pathing along the nodes is going to be. So we can use add edge to add a direct path where the state will go from that first function directly to the next one with just the add edge method. So of course, once we get the YouTube details, what we want to do is then generate a report. But once we've generated a report, what we want to do is go to the reflection step. And additionally, once we do title generation, which we haven't gotten to the connection there yet, we also want to reflect on that. And so our reflection step is actually where we're going to add in a little bit of our own logic to determine the different routing. So that when we do the reflection on the generating reports, if it's approved, we can pass it off to titles. If it's not approved, we can pass it back off to the generated reports, where it'll then go back to the reflection step until it's approved. And then also what we want to do is if we're generating titles, we want the reflection step, if it's denied, to go back to the generation of titles. And if it's approved, go to the end. So that's here where we're defining our conditional edge with add conditional edges. And then we have the reflect node. So both gen reports and gen titles is going to go to reflect. And then this is where we actually have to pass in a very specific logic function. So this is one of the quirks that I found in LangGraph, is that the routing logic when it comes to building conditional edges cannot actually be solely determined from a node's output. It must have an intermediary function that handles all of the logic to return which node to head to next. And so this is where our conditional edge, the verdict logic function, is defined here. So we're going to take in the state, and then our end goal here is we want to take in some of the different information from the state, determine what's happened, and then return back the next node that we actually want to go to. So what we're going to do is take in the verdict, which is going to look at reflection, and then the verdict part of that, and then take in the task. And so if the task is generating a report, that's when we know we're actually at the report generation step. And if it's approved, we want to pass in approve report. If it's denied, we want to put in deny report. Similarly, with the title generation task and at the title generation step, we put in approved titles or deny titles. And what this is going to allow us to do is that at this conditional edge, what we can do is if the report is approved, then we can pass it off to generating titles. If it's denied, then we put it back to generating the report. What we wouldn't want to have happen here is if it's approved, go forward, or if it's denied, go to the generation title step. So this conditional logic that we've defined here is where we're able to actually make sure that everything goes back to the right node that it's supposed to. Then, of course, if the titles are denied, it'll go back to the title generation step, which will then go back to the reflection step until it's approved. And if the titles are approved, that is the final end of our full graph, and all of that output will be put back to the user. The final step is just taking that workflow helper object and compiling it and saving it as a variable to create an invocable variable that we can then run this entire graph with. And so one of the other cool things that you can do is actually use IPython to draw a mermaid graph when you pass in the graph to show everything that's happening behind the scenes, which looks something like this. And it's not as pretty as what I've got all the way up at the top here that I clearly made myself, but we can see that this is exactly what's happening. It's going to the get YouTube details node. And then it's going to the generate report node. And then the generate report node is going to go to the reflection node. And the reflection node is going to determine where to go based on the verdict logic. If it denies the report, it's going to go back to the generation report and do this loop until it's accepted. If it approves the report, it's then going back to the generate titles node. If the generate titles node is denied, then it goes back to the reflection step. And if it is approved, it will go to the end and finally output. So the mermaid chart can be super useful for getting on the fly information about how everything is all set up here, including your intermediary logic functions that you have here. However, it can be a little bit confusing as well. As you can see, it tripped me up a little bit, even just going through all that. But it's a good way of visualizing it. So with that all being said, we now have everything all set up to be able to run our agent. Down at the bottom here, I have a couple examples of channel IDs if you want to grab them and you're running this yourself. But let's just also grab, well, let's grab Linus Tech Tips here, channel ID, because we just showed Ludwig for the example here. If you want to use LangSmith, there's also this integration, and LangSmith is LangChain's tracing service, and it's especially good for doing things that are super advanced like these graphs, because then you can see exactly what's happening at each step, and we'll check out a trace here too in a little bit once we actually run this, but let us go ahead and try this out. So all you need to do is go to .invoke on the actual variable name that you compiled your graph with, and then this kicks us off. So we had these couple input functions that would take in the channel ID and then the new topic idea. So I'm going to do a very relevant topic for me as I'm putting this video together, which is building a YouTube title generator AI agent with reflection using the new language model from Google, Gemma 2 9B. So let's run this in, and then it's going to start going through all of the steps that we defined in this order. So it's grab the YouTube details, it's going to generate the report, do all the reflection until that's approved, generate the titles, do all the reflection until that's approved, and then show us everything at the end. So I'll be back in a second here once all of this generation has happened, and then we can look at an overview of what's been going on. So we actually had a very successful first run. We grabbed the channel ID, the topic, grabbed the video details, generated a report, the reflection step approved the report, generated the titles, and then the reflection step approved the titles. So looking at that, we've got the Linus Tech Tips YouTube title analysis report, and then it says its key findings, had some intrigue and clickbait, some bold statements, aren't afraid to make strong claims or take controversial stances, some examples of that, some humor and personality, keyword relevance, and some implicit calls to action, and then puts these all into some good recommendations. Crafting intriguing and clickbaity titles with starting with a hook, don't be afraid to be bold, inject some humor and personality, optimize for keywords, for search, and then create a sense of urgency or curiosity. And so then let's look at the actual generated titles from Gemma. I built a YouTube title generator AI, and it's insane. Gemma 2 9B, can this AI write YouTube titles better than humans? YouTube title secrets revealed. My AI learns to write clickbait like a pro. Why YouTube AI title generators are the future and how to build one yourself. So I would say actually that these are pretty decently similar to Linus Tech Tips titles and are pretty good examples of output. So I'll actually be using one of these titles that was generated here in the video. And so we'll see then real time how it's performing. Hopping over to LangSmith just to get an idea of what this run looks like, we can see that this is sort of the path that it followed. So of course we get the YouTube details, which it'll go through, and these are all of the YouTube details. And then we can see that our current state here has no task, no topic, nothing, yada, yada, all that. Then it goes through to the generate report step, where we can see the actual prompt that Ollama and Gemma 2 9B saw. So it saw all of this, and then here's the pulled YouTube data that we input, and then the beginning of your response. Here's the output that it saw, and then if we look here, we should be able to see that the task was initiate, and that the new topic is here that we put in, this building a YouTube title generator, which is all stuff that's updated in the state from the get YouTube details, all of the different YouTube data, and then some blank stuff for the reflection. We can then see the reflection step here with Ollama, which takes in this report, returns this verdict of approve, no instructions, and then we see that we get the output of approve report from our verdict logic, which is the intermediate function that handles the routing, which then we know will pass it And we can see also in the state, it says approve, which will pass it then to the title generation. Title generation prompt is updated with all of this, and then it outputs this step, goes back to the reflection, which is then in this step, it says approve, and then all of the verdict logic is set approved. And then now we can see in our state, we have that the last task was generating titles, the new topic that we want, all of the YouTube data here, the generated report, the generated titles, and then the reflection verdict of approve, which then what we're doing down here and back in the code is I'm just grabbing all of the different parts of the output that we've saved and those parts of the state and then printing them nicely in Markdown here. So that's all fine and dandy and everything worked out great. If I look at a different trace from LangSmith, we can show you what it looks like when the reflection step actually denies. And it says deny, and then it thought that these titles that were generated, which the output was, I tried making, I guess my topic that I put in here was chewy brownies based on Ludwig's YouTube channel, all of these, and then its response was, its response was that the provided titles do not demonstrate a clear application of the YouTube title analysis report. And then it went through and tried to generate more and more titles, and it kept on getting denied until I actually figured out one of the downfalls, which was that it needed some additional context, which is why I started putting in the context parts into the different reflection steps and then also into the title generation step so that I would give an explanation as to why it made that title based on the report. Because then one of the downfalls that I found is that if we did this basic reflection, the reflection would then force it over and over back into sort of the more generic YouTube titles that a lot of the different AI systems would output. With that being said, my closing thoughts are that the Gemma 2 9B model for a local model running completely on my laptop and doing all of this analysis is doing a really damn good job. I think that the analysis was very in-depth and pretty decent. It's able to pick up on a lot of the different nuances, do categorical grouping, synthesize examples really well, and then sort of give clear explanations as to why it thinks what it's doing is what it's doing. The generation part and creating sort of different novel new content, I think still could use a little bit of work. I think it trends towards a lot of the more generic AI generations that I've seen. Things like if you ask ChatGPT or Claude to generate a YouTube title, it tends to take the same like part A, part B approach and not really do much great ideation as sort of new novel ideas. And also before adding explanations to the title, as I mentioned, the reflection step would loop back and back until I got these generic looking titles. But after adding that, we can see that it does still a decent job, much better than a lot of the bigger models almost, with generating these titles based on the context of the report that it's able to do. The final issue that I ran into is that context stuffing can be a little bit iffy. So as we're sort of putting in these prompts and adding in a lot of information, similar to what I was saying with the actual reflection step and putting in the YouTube data, with all of that information in there, it sort of lost sight of the prompt and the specific instructions that I was giving it. So it takes a little bit of tweaking to manage the context window, which is a decent 8,000 tokens, but also you have to be a little bit careful, especially with these 9 billion models, to be super clear and delineate everything very well so as not to confuse it. But overall, super duper well performing small model. I'm definitely going to be using this and analyzing it more, and it will probably be my go-to small local model for building for the current future until, maybe Llama 4 comes out and blows it out of the water or some sort of small local model is doing better. That being said, this was a great experiment and a fun little project to do. All of the code and further resources are going to be in the description down below. If you liked what you saw, leave a like. If you have any questions, of course, drop a comment. And if you want to see more like this and support the channel, feel free to subscribe. Thank you for watching.